Now let's see the system calls which are required in order to control a process. You need not remember all this, just know that they are there, that's it. So what it means is, every operating system, it should provide some mechanism, some system call in order to perform all these actions, and these actions are related to process. Okay, to control a process, there are various aspects in the computer system that a user wants to control, and for every aspect there has to be the code in the operating system, and for every aspect user should be able to call that code. Got it? Therefore I am writing you what are the aspects that we need coming to the process control, and the implementation actually depends on the operating system that is being used there. For example, I am just using the general names, and this exact name used for the system call will depend on what type of operating system it is and what convention the developers have chosen, right? Therefore there is no point in by hearting the names, just remember that they are there. Okay, now see this process control. Every process wants these system calls to control them. For example, we have end and abort. So a process, if it wants to end, right, at the end, if it wants to say that yes, I am done, then it can call the end system call. Then this system call will lead us to the code in the operating system, which will see that, oh, this process has been finished, and it will start the next one. And the next one is abort. So sometimes a process wants to abort without completing. There are various reasons for it, and it is that particular program dependent. Anyway, if a system wants to abort without completing, there are various reasons, then it can use the abort. So the implementation of it may depend on various things. So which means some people say that whenever a program has aborted without completing successfully, then the copy of it, that is called the dump, the memory dump has to be saved in the hard disk, so that later user can debug it, or he can see what has happened and why the program has terminated. And similarly, next one is load and execute. So a process can load another process into the memory and execute it. Some of the operating systems will give the control for the process for the user to do this, and some operating systems, they don't give the control to the user. So if you have to load and execute a program, for example, sometimes a program will not be allowed to do it. You have to write a script, right? And sometimes a process will be allowed to do that. That again changes from operating system to operating system. And the next one is create process and terminate process. So there are various mechanisms by which you can create a process, and one such mechanism is fork system call, which is used in Linux. By using the fork system call, you will be able to create a new process that is called as a child process, and similarly you can terminate a process that you created. Got it? And the next one is get process attribute, set process attributes. Sometimes you want to know what are the process attributes associated with this process, or what are the process attributes associated with some other process, right? Then you should be able to do that. So get process. Okay, what is process attributes means? I guess you remember what are the attributes that we have given to a process. So attributes are like process ID, what is its priority, who is its owner, right? And then what are the files that it has opened. All this, they are called process attributes, right? It can get the process attributes, and we can set the process attributes using the concerned system calls, and they are required to be provided because user wants to play with them. And the next one is wait for time. So some operating systems also call it as sleep. So sometimes we want to suspend a process for some time, then we are going to call the system called sleep, and sleep is provided by most of the operating systems, right? And you can set the time, sleep for 5 minutes, sleep for 10 minutes, something like this, right? So we can do that using the system calls. And the next one is wait for event and signal for event. These are nothing but these used for the synchronization, right? I hope you remember that down and up that we used, right, or wait and signal we used. So they can even be provided as a system call. This is nothing but semaphore implementation in the kernel. At the kernel, if you implement the semaphore and if you are using that semaphore, then you are supposed to use the system calls to access the variables of the operating system. See, if the semaphore is actually stored in the operating system, then it actually belongs to the operating system section, and you cannot go into the operating system directly, and you have to use the system calls. In that case, this wait and signal are going to give you. So if you execute wait on an event, then this process will be kept on a waiting list for that particular event, and whenever that event becomes available, some other process can signal that it is available, and this process can wake up. Just similar to how we have seen the synchronization techniques. And next one is allocate and free memory. So we know that we have used malloc and cloc like that. So even though when you are using malloc, memory alloc, so internally there will be the function system calls raised, which will lead to the allocation of the memory in the heap, right? So any operating system in general is supposed to provide system calls for all these facilities so that a process can be controlled. Okay, so like this we'll see all the aspects. What are the aspects that system call should be provided for? So one thing is program control. Let's see others.